Hello everybody, we're going to start chapter 13. Section 13.1 deals with antiderivatives and indefinite integrals. But before I start this, I've got to remind you about math in general. When you were little, you learned how to add, and it wasn't too long after that you learned how to subtract. Also, you learned how to multiply, and not too long after that, you learned how to divide. Well, math is always like that. It's a two-way street. So you work on something for a long time, and then down the road, you're going to turn right around and undo everything you've done. So the way I like to approach this, it is a little bit different from the textbook, but it is more common sense. It's a more common sense approach. So first thing we're going to do is take some derivatives, but slowly, because I need you to take notice of what you do, because you're going to have to reverse the process. Now, if you remember in these problems, I have got to go my exponent times my coefficient, decrease power by 1, derivative of a constant 0. So my y prime should be 3x squared. Excuse me, 9x squared. I didn't know why that box appeared up there. Let's try this one. I have got pretty much very similar problem. My constant's different. So on this one, if I get my derivative, it's going to be 9x squared. There. Okay. This one I got fractions. I've got negative exponents here in a bit. But I'm going to go exponent times coefficient. Decrease power by 1. So I am multiplying, I am subtracting. So 3/2 times 24, that should give me a 36. Decrease power by 1, I should have 36t to the 1/2. Let's see if I've got that. And then when I go 1/2 times 4, I get my 2, decrease power by 1. So remember, we are multiplying, then we're subtracting. Let's see down here. My f prime should be 12x cubed plus 33x squared minus 4x, because I multiply and subtract, multiply, subtract, multiply, subtract. And there that is. And it works also for your negative exponents. Negative 4 times 8, I'll have a negative 32, x to the negative 5. Remember, we subtract. Negative 2 times negative 9 gives me an 18x to the negative 3. 1/5 times 8 would be a positive 8/5 x to the negative 4/5. So there those are. So take notice of what you do. We multiply, we subtracted. Because what we do in this process, well, first of all, the integral sign is called, well, I just said it, integral sign. It's a symbol used to indicate you need to take the antiderivative, or the reverse of taking the derivative. Another word for it is to integrate. Now, another thing is if you had an S, a capital S, and if you got it on the ends and you pulled them, it would look sort of similar to an integral sign. When I do mine on by hand, mine look more like an elongated S, and that will come into play a little bit later. I'll talk about that here in a bit, much later on. So integration rule 1. For any real number where my n is not equal to 1, negative 1, and k is a constant. Okay, so I've got a number here. I've got x raised to some exponent. This exponent cannot be negative 1, because if it were, I'd end up with 0 in the denominator. Now, for me to undo everything that we did up there, remember we multiplied, we subtracted. Well, the k is a coefficient that came about from all this multiplication that we were doing. So I'm going to put the k, I'm going to hold on to it. I'm going to add 1, which is the reverse of subtracting. And then remember what we did earlier. We took the original exponent times the coefficient. Well, here we take the original exponent, divide. Now this plus c, that's called the constant of integration, because that problem we had earlier, let me go back, this one. If I had that on there, you won't know which way you have to go. So when I integrate this, I would have the 9 over a fraction bar. I'd have x, add 1, so I'd have a 3 as my exponent. I'd have a 3 in my denominator, plus the c, that capital C. And that would take care of 1 or 2. Unless I'm given more information, I can't find the original problem. We will be given more information, and that more information is a point. All they have to do is give me a point on the original curve. So that's integration rule 1. Another thing, if I have more than one term, then I do them separately. So it's still just a piece at a time. Now the problems I've got here on page 706, you can do those right now. I do have more examples on the following page using this rule. So I'd like to look at some of these. Now here's my original. My coefficient is a 1. So first thing I will always do, will put whatever my coefficient is that I've got in my problem over the fraction bar, and I wait. I'm going to add 1 to the exponent, and then I repeat. Now normally I don't indicate plus 1 because I can add 1. So majority of times I'd have 1 fraction bar x to the 10th, repeat, plus my c. Do not forget the c. I've got to see the actual exponent, so if it's in the denominator, first I move it up, and then I go. My coefficient here is a 1. I'm going to add 1. Well, adding 1 to negative 11 gives me a negative 10. Repeat here, plus c. So if it's in the denominator, if it is under a radical, you've got to get them up. They must be in this form. You have no choice. You've got to see the coefficient times x raised to whatever exponent. So no radical, no variable in the denominator, just move them up. Now number 9, I've got 3 different terms. So 4 is my coefficient. I'm going to add 1 to my exponent. So I get my 5 here. There's my 5. This is a repeat because I'm getting back to the original and I'm dividing by what had happened earlier when I multiplied. So my x is understood to be the first power, so I add 1. Now anytime I have a constant, remember this is understood to be a negative 6x to the 0. But when I go 0 plus 1, I get my 1. So you can do it like this initially, but I think you can still get to this part here. Now if you leave off the plus c, I will count off because that technically is not the answer. Now here's a problem where we can go find the exact equation. So the slope of the tangent line to a curve is given by this function. The point 120 is on that curve, so they want us to find the original equation. So I integrate both sides because I've got to get back to p of t. Integrate this side, I've got 2 pieces. See if I did that alright. I've got negative 10. Add 1 to my exponent. Repeat. Same thing here. My coefficient is 1. Add 1. Repeat. Plus my c. So clean up here. I've got 10 t to the negative 1 plus 1/2 t squared plus c. Negative 1 exponent, I move down. Now right now I don't have the equation. This is where this comes in. Now the t, if you'll notice, is in the x position, so the 1 goes in for my t. 20 is the p of t, so 20 goes in here. So if I have 20 here and 1 here, then all I have left is my c, and I can find it. So second, substitute the point. So it looks like c needs to be 9.5. Our original charge was to find the equation, so take your c value back, and that's what the original equation used to be. So I need you to go try those problems, and then I'll do some more problems here in a bit. Talk to you later.